There's a lot of chemistry going on in here. It's all because of atoms and molecules. How can we learn and understand this stuff? Take a look at this picture. Does a person learn this way? Stop the video and answer that question. And the answer is no. Knowledge is not pumped from one person's brain to another person's. You and I have been in this situation before. We only learn 20% of what we hear. We only learn 20% of what we hear. Check out these other numbers. So what is the best way to learn chemistry? Stop the video and answer that question. And the answer is D. We learn 95% of what we teach. Research shows that learning occurs by actively making connections to what you already know to new information. A good way to make those connections is to interact, that is, talk, discuss, review, explain with other people. Einstein said, "You don't really understand something until you can explain it to your grandmother." Stop the video and fill in this blank. And the answer is one very valuable skill that you want to learn to improve your life as well as others is to learn to solve problems. Problem solving is what you do when you don't know what to do. Here is a problem solving model we've probably been told to use. The problem with this model is it assumes we know what we're doing. Here is a more likely model. Stop the video and read the steps. One important step is to try something, see if it works. You want to test intermediate results to see whether you're making any progress. Write down an answer. Make sure you test the answer to see if it makes sense. Note that problem solving is very messy. The first time you try something, or the first few times you try something, is very hard and you're not very good at it. Deliberate practice is a way to improve your skills. This is very focused, concentrated practice of a specific skill. Deliberate practice consists of breaking the skill up into small parts. You want to practice retrieving information. Quizzing yourself is a good way to do that. Think of deliberate practice as short, intense bursts of practice. So space out your practice. Do not cram for many hours before a test. Feedback is very important to make sure you're retrieving the right information and developing the right skills. An expert such as a coach or teacher is very valuable in giving feedback. Apply deliberate practice to learn skills to accomplish your goals, like be a doctor. In Chem 1A, we looked at properties of substances, how substances undergo chemical reactions, how energy is involved in every chemical reaction, and did chemical calculations which make predictions. Stop the video and review the skills that you learned. So let's apply your knowledge and skills. Your drink is too strong. Would you use water or oil to make it less strong? And why does your oil and vinegar salad dressing separate after shaking it? Stop the video and spend a minute or two answering these questions. We can answer these questions by looking at the properties of substances. For these two questions, we will look at solubility, which depends on polarity, which we can determine from the structure and shape of the molecules. Let's take a look at water. Stop the video and review how the structure and shape of water determine its polarity. The bent shape of water and its polar bonds makes water polar. So since water is polar and ethanol, the alcohol in a drink, is polar, we can apply the like dissolves like rule to make our strong drink less strong. It turns out oil is nonpolar and vinegar is polar. The nonpolar oil will not dissolve in the polar vinegar. That's why we see two layers in our oil vinegar salad dressing. Valence shell electron pair repulsion theory helps us determine the shape at a central atom. We just looked at the bent shape at the oxygen water due to two bonding pairs and two lone pairs on oxygen. Stop the video and fill in these blanks. And the answers are, and here's an example. Oops, I spilled this substance on the floor. Would I use water or oil to clean it up? Stop the video and apply your structure, shape, and polarity skills to answer those questions. And the answers are acetone, vinegar, and baking soda are all polar substances. Since water polar, those polar substances are soluble in water. Vegetable oil is nonpolar, as is oil, so we can use oil to clean up the vegetable oil. Smells are also chemicals. This is the code name for just cooked bacon cheeseburger-like fragrance. Restaurants use this compound to make their customers hungry and buy more. One of the most direct assaults on the senses arising from environmental pollution comes from the stinks of civilization. These compounds have different smells. Our smell receptors are in the olfactory cleft on our nose. For some smells, only 8 molecules are needed to trigger the receptor. We've smelled ammonia before. H2S smells like rotten eggs. Ethylene mercaptan stinks. Axel and Buck won the 2004 Nobel Prize in Medicine for their work on smells and odors. They found that different compounds activate different receptors which result in different smells. Smell or odor also influences flavor or taste. Linnaeus, all the way back in 1750, described 11 different tastes. However, here are the 5 basic tastes. You college students know what umami tastes like. We have about 9,000 taste receptors in our tongue and soft palate. Our taste threshold for sour is much lower than it is for salty. These 3 compounds have very similar structures. Stop the video and figure out how these compounds are different, which affects the taste. And the answers are: many smell and taste compounds are organic compounds. Turns out that most compounds are organic. There's over 16 million organic compounds known so far. Organic compounds contain these elements to remember these general bonding rules to help you draw the structures. Biomolecules, carbohydrates, lipids, proteins, and nucleic acids are also organic compounds. Since there's so many organic compounds, these compounds are classified by functional groups. A functional group is a small group of atoms within the organic compound. For example, acetone is a ketone, vinegar is an acid, and ethanol is an alcohol. Each functional group has specific properties. Many organic compounds are very big. A shortcut to drawing a Lewis structure is to draw a skeletal structure. In a skeletal structure, the carbon label and all the H's bonded to carbon are not drawn in. In the next video, we'll take a look at organic compounds and we'll use these skeletal structures.